Friends, welcome to our complex analysis video series. In today's lecture, we will discuss in the continuity of analytic functions. Again, we will take some more problems related to the analytic function. So, in today's lecture, we will deal with some problems regarding analytic functions. So, let us see some MCQs related analytic functions. See here, we have taken the problems. Fz is analytic functions of z, then del square upon del x square plus del square upon del y square modulus of real of fz square equal to 2 of f dash z of square, del upon del x of real of z of square equal to 0, del square upon del x square real of fz square equal to 0, and this is del square upon del x square plus del square upon del y square of real of fz whole square equal to 0. So, this is the options related to the problem. Friends, here because the problem is related to the analytic function of z. So, what it means? It means that fz is equal to u plus iv, as we know this is the complex functions, and where z equal to x plus iy. So, here real of fz is what? Real of fz is u. So, I have putting here real of fz equal to u. Now, come to the del square u upon del x square, del square u upon del x square. So, 2u del u upon del x on multiplying both sides by del x, and del square u square divided by del x square equal to 2 of del u upon del x square plus 2u del square u upon del x square. Because this is the options format, that's why we have taken the result like this. Now, del upon del y of u square becomes like this. On adding del of del x of u square and del of del y of u square as like this. So, this result left hand side can be written as del upon del x plus del upon del y of u square should be outside, here 2 should be outside, and this is del u upon del x of square plus del u upon del y of square, and this part becomes 0. This part becomes 0 because u is the harmonic function. This is the harmonic function because when it satisfies the Laplace equation, this is the Laplace equation, that means u should be the harmonic functions. So, this part is 0. Now, del by del x plus del by del y of u square equal to this one, and by using the CR equations it becomes, and taking modulus both sides. So, modulus of u of square equal to this one, u of f dash of z of square, because f dash is del u upon del x plus I del v upon del y, this is the f dash z. So, the result is like this. So, this is the options. Now, come to the another problems. Fz equal to this one is analytic, and when u equal to z equal to x plus iy, this is not u, this is x, and here u minus v is given. Friends, in previous video we have already discussed the problem based on when u minus v is given. Here is again repeat the same functions. U minus v is given, e to the power y minus cos y cos x plus sin x divided by cos hyperbolic y minus cos x. So, this is the options. So, you just use the same problem, fz equal to u plus iv on multiplying both sides by I of I. So, it becomes I of fz equal to I of u minus v, and we will find the result in terms of u minus v and u plus v. So, this is u minus v, and we have indicated here the capital U and capital V format. So, u minus v is this one, and because u minus v is denoted by capital U, so del u upon del x is this one, and when you got the result del u upon del x, and this is nothing, this is the phi 1 x comma y, because I am after getting this type of result we will use the Milne-Thomson method, that's why we have indicated here the phi 1 z comma phi 1 x comma y, and this is the phi 1 x comma y, and x should be replaced by z and y should be replaced by 0. So phi 1 of z comma 0 becomes like this. After simplification, this phi 1 of z comma 0 becomes the result minus half of cosec squared half of z. Now come to the another result, that is del v upon del y, and that should be denoted by phi 2 of x comma y. So this is phi 2 of x comma y, and after substituting the value of x should be replaced by z and y should be replaced by 0. So phi 2 of z comma 0 becomes 1 minus cos z divided by 1 minus cos z of whole square. 1 should be cancelled, so it becomes 1 minus cos z, and 1 minus cos z hence should be written as 2 sin square z, and so 2 sin square z is written as 1 by 2 cosec square half of z. Sorry, 1 minus cos z becomes twice of sin square z by 2, so it becomes half of cosec square z by 2. And by using the Milne-Thomson method, and you will substituting the result and find minus half of 1 plus I integration over cosec square half of z of dz, and the integration of this result becomes cot z by 2 plus c divided by 1 plus I. So fz equal to this one. Since fz is half of pi by 2 and that equal to 3 minus I divided by 2, so after substituting this result, c divided by 1 plus I equal to f of pi by 2, and f of pi by 2 becomes, because fz is given, cot z by 2 plus c divided by 1 plus I. So this result becomes cot of pi by 4, because cot of z by 2 is given. So on substituting the value of z equal to pi by 2, so it becomes pi by 4, and the result becomes 3 minus I divided by 2 minus 1, so it becomes minus 1 minus I divided by 2. Therefore the value of c is 1 minus I divided by 2, and on substituting the values of c here, and you got the result. Now come to the another problem. Fz equal to e to the power z of minus 1 by 4 when z is not equal to 0, 0 when z equal to 0. So fz is analytic at 0, 0, limit of z tends to 0, fz is exist, limit of z tends to 0, fz is not exist, CR equation satisfied at 0, 0. So these are the options. So friends, what is given here? We have given here the format fz. So actually there are so many solutions A, C and D. Let us see how it is possible. Limit of z tends to 0, fz equal to limit of z tends to 0 e to the power z of minus 1 by 4. On approaching the z tends to 0 on x-axis, so it becomes the result is infinity, sorry 0, and when z approaches to y-axis, so it becomes the value infinity. That means limit of z tends to 0, fz does not exist, because when we taking the approach of z tends to 0 along the x-axis, it becomes 0, and when we taking the approach at z tends to 0 along the y-axis, this is infinity. So that means limit of z tends to 0, fz does not exist. Now come to the another point. Fz is u plus iv, so u plus iv becomes e to the power minus divided by x plus I y whole to the power 4. So just you simplify this part on multiplying the conjugate, this result becomes minus of x minus iy whole to the power 4 divided by x square plus y square whole to the power 4. So after comparing real and imaginary part, so u is this one and v is this one. So u of x means del u upon del x at 0, 0 point, it becomes limit of x tends to 0, u of x comma 0 minus u of 0, 0 divided by x. So after substituting, it becomes the result 0. This is the partial derivatives of limit form at the point 0 0. Now similarly the result of del u, sorry, here is y, del u of 0 0 becomes limit of x tends to 0, u of 0 comma y, this is y, y of 0 comma limit of y tends to 0 here, u of 0 comma y minus u of 0 0 divided by y becomes like this. Similarly v of x we will define, v of y we will define, and we conclude here कि u of x and v of x, u of y, v of x is equal to 0. That means CR equation should be satisfied. Now f dash z is limit z tends to 0, fz minus f of 0 divided by z. On substituting the value z here, on simplification it becomes the infinity. So f dash 0 does not exist, hence the given function is not analytic at 0 0. So these are the options. Now come to the another problem, which of the following is not a harmonic function. So first of all, what is harmonic function? Those type of function which satisfy the Laplace equation, that means del square u upon del x square plus del square u upon del y square equal to 0 and del square v upon del x square and del square v upon del y square is equal to also 0. So this is the format of harmonic functions. So here we have indicated here u of x, u xx plus u y equal to 0. So you satisfy the harmonic functions. This is the option format. You just have to check this result. Now come to the another problem. So again based on the harmonic function. A function is said to be harmonic if. So the option is clearly here. There is A and B. Now come to the another problem. The value of k for 2x minus x square plus ky square may be harmonic if. So just you go through the process of harmonic function, because here you will define u and v. So only u is given here. So just you satisfy del square u upon del x square plus del square u upon del y square equal to 0, and by substituting the values of the results and you will define the values of k. So here I think B is the correct option, and just you go through the solution part and then check it. Now this is the u and v are called harmonic conjugate function if are harmonic and u plus v be analytic function, u and v are harmonic function and u plus iv may not be analytic function, u and v are harmonic function and u plus iv is analytic function. So only option A is correct. U and v are called conjugate harmonic functions, means u and v harmonic function and u plus iv be analytic. This is the format of harmonic functions. Now come to the another problem based on harmonic function here also. Let u be the harmonic function, then harmonic function satisfy the differential equation like this. U satisfy Laplace equation. A harmonic function had a functions do not satisfy the formal differential equation like this. So only B is the correct options, because Laplace equation should be satisfied, and this is the format. Now problem number 9 MCQ is the curve C1 is like this and V is given are orthogonal, and friends, we have already defined the orthogonal, and based on the orthogonal we have taken some examples also. So before doing this type of problems, first you go through the particular of orthogonal videos, and then you will easily define the problem based on orthogonal problem. So here u and v are complex function, u plus iv analytic function, and u minus v is analytic function, and u plus v is analytic function. So here is the correct option, u plus iv is the analytic functions. Now the CR equations and for fz equal to this one is analytic. So this is nothing, this is the simple CR equations of the necessary part, del u upon del x equal to del v upon del y, and del u upon del y equal to minus del v upon del y, del v upon del u upon del y equal to minus del v upon del x. This is the again the problem based on CR equation of the polar forms. This is the polar form, fz equal to analytic u plus y f dash z. So f dash z is nothing, this is del u upon del y minus I of del v upon del y. So friends, what we have discussed in today's lecture, we just have taken some more MCQ based on analytic functions. So thank you all. We will discuss in the continuity of complex analysis video. We will discuss in the next module of the complex analysis. So thank you.